So yeah, I get to talk about programming experiences and programming language design and all of these things from kind of a different perspective than most people. I get to talk about it as neither an academic nor as somebody from industry, but instead as someone in a startup doing all of this, which is kind of a weird place to be for a number of reasons. For one, we're on this kind of unusual timeline when it comes to these sorts of things. But for two, we have a very small team trying to do something very, very ambitious. And if you've never heard of Eve, our goal is to basically bring programming to everyone, or whatever that may mean is kind of an interesting question. The way we've kind of defined it is sort of in the original sense of the bicycle for the mind, right? We think that computers provide an incredible amount of power to those who can control them. Currently, that's largely people like yourselves in this room, right? It's programmers, people who have spent an immense amount of time learning how to do exactly that. And so, being a startup, we have the sort of mantra of like constantly testing things out with real people, right? Which is something that we actually don't do a very good job of when it comes to our own tools in the industry. And as a result of that, we've actually gone through many, many, many versions of Eve. So we've been working on the project for about 1.5 years now. During that time, we've done easily over 20 different versions. And so what I thought would be a kind of interesting talk, especially for this group, a group of people interested in exploring this space, would be to just go through some of them and tell you about some of the things we've learned along the way. So let's start out. The very first version that ever existed, I actually showed at this conference 2 years ago. It was called Aurora. And if you wanted to start going about making a version of programming that's better than what we currently have, any reasonable person would start from their own beliefs about what better even means, right? And in our case, or in my case, I thought, you know what? I really like Clojure. I really like immutable data. I really like functional programming. I really like sort of this REPL, almost Mathematica, notebook-style way of working with the world. Let's just build an entire platform revolving around that. Can we make that workflow really, really nice? Can we make that fluid? Can we make it efficient? And what would we learn doing so? So I built this Aurora thing. And in this case, you can kind of see in the background what's going on here. I'm taking a bunch of data, and I'm performing these very Clojure sequence-like operations on top of it. In this particular instance, I was getting some usage data out of Mongo and transforming it, and extracting the times out of these things and whatnot. And I go a little bit further along and do some math, which you can see here is shown as math. This was another big thing I was really interested in after Lighttable was I want to represent domains as themselves. And then at the end, I want to be able to get a graph of something really, really quickly. I did all this work, so I can just stick a chart on here and drag some data to it, and ta-da, I get a chart. So this was an interesting prototype. Like I said, if you were here a couple of years ago, you probably saw it. I went on to demonstrate, hey, this works for more than that. You can actually build real applications this way. My sort of proxy for a real application in this point was building to do MVC with it, right? Something that actually, traditionally speaking, doesn't seem like it would fit a world like this super well. In the past 2 years, though, we've learned that's quite the opposite of true, right? React has sort of brought a lot of this attention towards, let's do these very data-focused, there's a single data structure, everything is just a view over that data structure, sort of way of looking at the world. And I kind of built this environment before that kind of stuff existed. But I mentioned it isn't just about getting a version of programming that maybe I like more, right? The goal was to get more people to do it. And this was something that was an original goal of Lighttable. And what we found was Lighttable can make you more efficient. I mean, big surprise. Being able to ask questions of your software, being able to execute code in real time, of course that's going to make you faster. Original thought was it might actually make programming easier. But it turned out it didn't really. Programming is still hard. And so, we took this prototype and we sort of did some more with it. We tried to make it look a little bit better. We got rid of the weird data structure-y thing and turned it into tables, right? Basically a vector of maps is just a table, and if you have just vectors, they just represent as lists and so on and so forth. And Again, kept this sort of notebook style of working. And that was cool. We took it even further and like, well, okay, something that you can't see is a little too small, but we'll have some code over here on the right. You have your notebook over here on the right, and you can imagine this big white square in here is like a document that you're building or the page that you're building. Maybe you're building something like to do MVC again. And unfortunately, I couldn't find a screenshot of the really nice version of this. So we worked on this for a few months, got something that I would have used. I really liked it. I thought it was interesting. And I had an opportunity to go to the opening of Brett Victor's lab in San Francisco. And this was like the perfect opportunity to test this thing out because there were a bunch of people, yeah, there were programmers there, but more importantly, there were a bunch of non-programmers there who were incredibly intelligent, right? The reason why I want to give people this superpower of being able to control a computer is because I want the guys curing cancer to be able to cure cancer faster, right? That's what I want. I don't want more software in the world. I want more solutions in the world. And so I needed to be able to test this out with those kinds of folks. And the opening of the lab gave me the opportunity to do exactly that. And so I showed my prototype, and people loved the idea. They thought it was beautiful. It was really interesting. And I sat a few of them down and had them try and use it. And amazingly enough, the usability of it was actually kind of okay. Like, people got around in it. They could do some semi-interesting things. But it turned out the model itself didn't work for them, which was not what I was expecting. Functional programming didn't make a lot of sense to them. And what it ended up being was something I never would have guessed. The thing that we just absolutely could not fix was scope. And of all the things we showed people, all the tests we did, we could never come up with a way to get people to get their heads around scoping. And you think, well, that's not so bad until you watch their actual reactions, right? You learn so much, not statistically or any of that from user tests. You learn it from people's reactions, what they actually say to you and what they try and do. And I will never forget the guy who had like this set of nested things, and he had a value at the end of the chain. And he goes, I want to use that up there. I was like, you can't. It's like, why not? I see it. It's right there. I want it here. Well, you can't do that. Okay, well, can I take this and put it down here? No, right? And you're like, try and think about how you explain why that has to be true. And that's the important part. Why does that have to be true, right? Well, the programmer in you right now might be saying, well, scope's important. Like, scope is how we have functions. That seems kind of important. And we found that dealing with lots of data structures and nesting them is sort of creating another version of this exact same problem. And so we realized, hey, you can't really have scope, and you can't really have these like deeply nested data structures. Well, if you don't have those either, then you don't have anything. If you don't get rid of data structures, you get rid of anything that can hold things in order. What does it even mean anymore, right? Like, that is the definition of programming, a set of operations, an ordered set of operations over data, and I just removed all three of those things. So it was like, well, maybe that's kind of scary, I don't know that that's going to work. But actually, if you think about it a little bit, there is a massively successful example of a thing that works exactly like that. Excel is exactly this. Excel has one data structure. It's a giant grid, and there's problems with that, and we can talk about that later, but it has one data structure. There is no scope. I can access anything from anywhere. If I see a value, I can use it, right? There's no inherent ordering to it. Execution's not ordered. I can sit there and sort things however I want throughout all of it. And that is a wonderful, wonderful realization, because our goal is to let everyone do this stuff. And Excel is unquestionably the most successful programming environment ever built. Even though we don't traditionally think of it that way, it is exactly what it is. Hundreds upon hundreds of millions of people use it every single day to do amazing things. And when we figured this out, I had the opportunity to go talk to a bunch of them. And I had the opportunity to talk with somebody at a Fortune 500 company, and they had this spreadsheet. It was measured in gigs in size. It had been built over a 10-year period. Not once had a professional programmer ever touched this spreadsheet. What was amazing about it was that it modeled their entire business. A Fortune 500 company inside of a 10-plus gig spreadsheet. And the funny part was, anytime they wanted to make a change to it, they'd make a change and then go to lunch, because it took an hour and a half for it to coalesce, right? But the important bit here is non-programmers built an amazing piece of software without ever calling themselves programmers, without ever thinking of themselves as programmers. And it's a truly complex and amazing thing. Of course, the problem with Excel is it's very constrained, right? How would you build, say, a website in Excel? How would you build a game? How would you build any number of things that just don't naturally fit into this like two-dimensional grid way of thinking about the world? And so we looked again. We dug a little bit deeper and like, well, is there anything else maybe that works this way? And there is one other example that is exactly this, and that is relational databases. Relational databases have no inherent order, right? You can, including even in the code, the execution is not guaranteed, or does not have a specific order to it. No scope, barring access rules, I can get anything from anywhere. And yeah, there are functions, but only scalar ones, right? They do much, much simpler things. And that, again, is a wonderful sort of realization, because if Excel is wonderfully usable by lots of people but constrained, databases are maybe not super usable by everyone, but amazingly flexible and powerful. The world runs on relational databases. At some point, every bit of data eventually kind of touches one. So, where do we go from there? We did this little thought experiment. We want to program without scope and data structures and all these things that I never thought we would do. Well, there's some very, very interesting research that you are actually going to hear about tomorrow. The keynote speaker tomorrow, Peter Alvaro, worked at or studied at the BOOM lab at Berkeley, the Berkeley Orders of Magnitude lab. And their stated mandate was to make programming orders of magnitude smaller, orders of magnitude simpler, orders of magnitude faster, right? All of these lovely qualities. And they did so by taking a 40 years dead language called Datalog. We just heard about Prolog. Datalog is like Prolog's little cousin, specifically designed for databases. And they added time to it and found, hey, we can build distributed systems this way. And it's really compelling. And I'll let him tell you more about that, and I'll tell you a little bit about what we did with it. So one of the problems with Prolog is its predicate logic, and that's hard to understand. But we had this intuition. And this intuition was that if you think about predicates as kind of fill-in-the-blank sentences, and if you think about horn clauses as, when you see this, I want you to do this, kind of backwards from how horn clauses normally are, you get something that feels a little bit like a mix between Codu and like, I don't know, pattern matching, unification kind of stuff, right? And I mentioned I was going to show you some stuff, so let's actually take a look at this prototype that I built. And this, interestingly enough, is the prototype we eventually raised money on. This is a fairly early version of it. But as I was saying, it is a system where you have these when you see this, do this kind of rules going on. I'm going to make it a little bit smaller here, or not. When you see this, do this. And what's interesting about that, and one of the realizations we had, is it kind of ends up reading like a specification a bit. Like, when you're setting defaults, remember that the counter is 0. When you have a counter as some value, draw it as a button with these, with this information in it. And when the incrementer is clicked, change the counter as some value to the counter as some value plus 1. And this creates a lovely button that is very powerful and useful. It can count numbers. Now, as a fun side note here, one of my colleagues and I did a talk where we went, and before we did it, we had a bunch of programmers, professional programmers, try and write that program. A button on the screen that just simply counts the number of times it was clicked. My my Oxford and Cambridge trained mathematician and computer scientist colleague took 30 minutes to write that program. And that is not because he is a poor programmer, he's brilliant, right? It is because there is so much that goes into just writing something even that simple. And the idea here was, well, if we have this wonderful platform, or this wonderful way of thinking about the world, when you do this, you see this, and it's just kind of like this database married into a language, you can get rid of a lot of the complexity. And so we built To-Do MVC, of course. Unfortunately, it renders funny in a very small screen here. But hey, we built it. Actually, this turns out to be really fast. When you build a language where every operation ends up being sort of just an operation on a B tree, because technically speaking, all this is a database. All we're ever doing is querying for information and sticking new tuples in the database, and that's it. Turns out when you have that, you can actually make it pretty darn fast. It's very memory efficient, and lots of good things start to happen. But again, we have this Mad Lib kind of way of working, right? This fill-in-the-blank sentences thing. And you can see here you get lovely lines like when filter active is clicked, change the filter, or filter the to-dos by whatever it currently is to filter the to-dos by active. Again, you're sort of just describing this sort of, I guess when you see this, do this, sort of declarative flow. And interestingly enough, this was actually bootstrapped. It was written in a ClojureScript DSL. This actually all runs in the browser. And so that's why some of these are blank, because we didn't actually have Mad Libs when we were writing it, right? It's in this DSL. Here's the interesting part. Much like the Bloom guys, who found that they were able to rewrite Hadoop in a style like this in thousands of lines of code instead of 2.7 million lines of code, I wrote the IDE, all of this stuff, in about 600 lines in a week in a language that had bugs and didn't even have aggregation in it yet, right? It was an amazing result for me. I mean, as someone who knows exactly what goes into building these sorts of things, it was impressively small. It really was orders of magnitude better. That being said, we found some interesting aspects to it. One was, turned out that like specification way of thinking about the world, where you were again sort of looking at almost instructions to the computer, wasn't really all that much better than programming as it normally is. It's like one of those, we like to talk about all these like holy grail problems we've sort of started to nip away at a little bit as we've gone on this program, or on this project rather. And of course, executable specifications is one of those. And I actually don't believe in them as much anymore as I used to. The notion that you were going to write some sort of English specification and have it work, I think we could do that. I actually think if with a little bit more work, this would look a lot like it. But the problem is, if you think about English, think about the English paragraphs that would describe to-do MVC or whatever. You can actually get it. There is an English specification for it. Every single line relies on knowledge about the previous lines. Every single line is mired in context, which is the exact problem we have with programming to begin with, is we're trying to figure out where things fit in this like massive system, right? And if we are forced to constantly sort of have the whole thing in our head before we can understand any one bit of it, then we actually haven't gotten anything. And when we tested this out with people, that's basically exactly what we found. They could read the program, they thought it was cool, they understood what they read, but it didn't actually help them program anymore. And it didn't actually give them a sense of sort of how the whole system worked until they got to the very end of every single one of the rules, right? And so that was kind of one of the interesting bits of learning we got out of that one. But in any case, this was very compelling. We had proven that, hey, the guys at Berkeley had shown you can build distributed systems with a data log-like language. We just showed you can build websites with it. We just showed you could build an IDE with it, right? And that's a very different way of thinking about the world and a very different set of results. So we wanted to explore other ways of working with it. In this video, it will be a little hard to see. The details aren't important. I'll explain kind of what's going on here in a second. But one of the things we knew we liked, right? I had mentioned Excel. And Excel is, again, widely used. Can we make it look like Excel? I mean, if you think about the sort of operations you do in SQL, things like joins and unions and filtering and all that, they all have pretty natural visual mappings to operations on a table, right? If you think about join, you're literally taking two columns and sticking them on top of each other. Union is taking two tables and glomming them onto each other. Filtering is, just clicking at the top of a column and saying, I only want, values greater than 5 or whatever. And so we explored this idea of, hey, let's just represent everything as a table and see what happens. And so this was one of the first times we got Eve to do something to the outside world. This is the first time we had Eve send us a text message. So the way we did this was, like I said, don't worry too much about what's going on here, but there's a set of tables over here on the left with a set of columns inside of them. And we're dragging columns out onto the surface here and kind of renaming them. And I didn't describe it, but the way we think about sort of events and interaction and the outside world is just as, again, information stuck inside of a table, right? So when you get a click, you do not get a click event. All we do is stick a tuple inside of a clicks table or whatever. Then you write views over top of that table. So if I want to write the incrementer button, what I do is count the number of clicks in the click table, right? And that's kind of what's going on here is I have a set of buttons down there at the bottom that have our names on them, and I click on them, and we got a bunch of clicks. And then I joined that to the users table, which has their phone number in it, right? And the way we affect the outside world, because the only thing that exists inside of our system are tables and views, the way we affect the outside world is writing to a table. So we have an SMS outbox table, and I'm going to basically map that view at the top to the SMS outbox table. And so for every row in the first view, I get a row in the SMS outbox. And for every one of those, there's this magical little thing sitting on the outside of our world, waiting for new things to go into that table. And when they do, it does something with them. In this case, sends us a text message. And so that's sort of the way we think about the outside world. We think of it as, when you're playing inside of Eve, you're playing in this world where all we have is data, right? There's nothing else going on. You have data, and everything you want to do is expressed simply as a view over that data. But the truth is we can't live that way, right? We can't not have drawing to the screen. We can't not have going to the network or any of these things. But the way we do it is that interface is still itself data, right? If I want to affect the outside world, I stick a thing in a table. If the outside world wants to affect me, if like a web request comes back, right, then that comes in as a tuple, as data into the system. And so what that means is that the entire system is inherently reactive, right? I never write code to talk about sort of how things change. I just write views over the data that already exists, and they get updated as they go or as new information comes to light. So we built that version where we were showing tables, and we kept trying to bootstrap, and we kept ending up in these like weird places where we needed to experiment more with the platform and understand the semantics of the language, but the editor wasn't really there to do it, and trying to do it all in tandem was kind of complicated. So we built this version that had a much more traditional, albeit not very good syntax, as we found, where you wrote some stuff in a text editor, and then the sort of interesting bit was that we showed you all the tables that you were building to make this like association very clear. So I'll show you that one. So this ended up being one of the more interesting ones because we took it further than we had gone before this one. So we'll go through the short little tutorial here. So in this syntax, which again, don't get hung up on, it's really bad, but it worked for us. So in this syntax, you declare a new view by putting a star in front and you give it a name. So this is the user view. And I give it some, this is a way of sort of inserting data directly inside of your code, right? I give it a set of headers, and then I just add rows. And I, of course, could add another row in here. Rob is 32 or whatever. And you notice it's all live, it's all reactive, which is probably unsurprising coming from me. But we'll go on here and say things like selecting the year born, right? And so this means select from the user table, get the age column, and born is, some simple calculation over that thing. And we get a little more complicated, we can do a join. And if you've ever done Prolog or Datalog or any of these things, we have sort of this implicit join mechanism. If a thing has the same name, then it's joined, right? And so you can see here that user and year born are joined on the age thing because they both have age as their name. And so that gives me age, born, and name. And here is an example of like aliasing that in case you have things that you want to join that don't have the same name. Obviously, you need some way of doing that, and it makes the values over here nicer as well. Let's go to something else. So filtering, that's probably unsurprising. Or, filtering, more complicated filtering. This is filtering on some predicate. And here's where it got interesting. So this is how you wrote an aggregation. And this is something, for what it's worth, talking about lessons we've learned. Turns out aggregations are really, really, really hard problem. Many of the versions of Eve we have written have been because we were trying to figure out how to make aggregation work correctly. And this one had an interesting way of doing it, but maybe not the greatest way of doing it. What this allowed you to do was inside of one of your views, you could aggregate over another view. And that did not affect, unlike SQL where you say group by, and that affects your actual query. In our case, you could aggregate inside of a query, almost like it were a sub-select kind of thing going on. And that enabled us, I'll show you a little bit later, that enabled us to write, remember that to-do MVC application. The one I showed you before was about, I think, 140 lines. The to-do MVC we were able to write in this one had only 15 lines that were devoted to logic at all. Everything else was just rendering stuff. So you can aggregate, and here's how you draw things in this. If you've ever seen Hiccup in Clojure, or sort of JSX is kind of this way too in React land, you create a sort of a data structure, and then you feed that to something that turns that data structure into HTML. And you'll notice we got some UI when I uncommented that, right? So enough of this. Let's go look at some funner, some more interesting things. So here's a clock written this way. This is all just drawing it and me being terrible at math. But I mentioned before, like when we want to sort of interact with the outside world, the way we do it is by sticking information in tables. And so I wanted a timer. So I created a little, I basically said I want to stick into the timer view this row. And I gave it some ID. I have no idea why I chose 3. But, and I wanted to, when it's going to tick, I wanted to give some event, and that event is tick. And I want to do it every 1,000 milliseconds. And so that means is now there's a thing on the outside of the system sticking tuples into our world once every second. And that's how the clock works. And so all we end up doing is going over the events table. That's what this guy is. Looking for the label of tick, because I said the event was called tick. And then I get the maximum. I get the latest is basically all I'm trying to do. And then I just turn that into hours, minutes, and seconds. And so that's how you write something like a clock. This also extends itself to, let's see here. Extends itself to doing recursive things, right? So we can do graph traversal here. So, I have a bunch of edges from A to B, B to C, C to D, D to A. And I state that there is a path from, for every edge is from and to, and there's another path where if there's an edge from A to B, and a path from B to C, then there's a path from A to C, right? And this extra thing here is an unfortunate requirement of our syntax where the names had to match up in order for it to work out. So you can kind of ignore that, but this allowed me to specify basically the parent ancestor query that every Prolog intro has in it, right? And once you have recursion, you can, of course, write a Turing machine. So, we wanted to prove, hey, this crazy language that only has views over time and basically works over an immutable event log can, in fact, do anything we need it to do. And the way this works is kind of interesting. So it represents the tape finitely, even though technically speaking it is infinite, and we only sort of like reify the portion of it we have values for. I can't remember exactly what this one does. I think it adds 1 and 2 or something like that. A wonderful state machine. And of course, the incrementer button, which, the screen's really small. That fits in a tweet, which is pretty cool. That's the measure of good programming right there, I'm pretty sure. What's interesting, though, in this, and the reason why I'm showing it, is this little line here makes it so that this incrementer button event, the set of events related to this, are now shared. So this made this program, this line right here, made this program distributed. Right? And I mentioned before that the original research here is all about sort of building distributed systems. And so we get a lot of very interesting benefits out of the fact that essentially our language is nothing more than a bunch of a bunch of pure functions, more or less, over tables, right? And so, we implemented chat programs and all that. But I think the interesting thing to show, not that one, this one, is that once again, this is all bootstrapped. So all those tables, all the running UI, all that stuff that you saw was actually rendered by Eve itself. I turned off line numbers because I wanted to conserve space, but this editor was written in 200 lines. The cool part about this is not only is it drawing all of this, but it is actually pushing code around to run your program in another place. So I've got the editor running, right? And it is also running your clock program or whatever, right? And you can't have those running in the same database at the same time because their events would be sort of messing with each other. So what this actually does is stick a bunch of facts inside of a remote code table and tells it that, hey, we want you to go execute this in some other place. And so it executes it in some other place, and that's what allows the clock here to update without necessarily updating the editor here. Though you'll notice it is updating, and the way that's working is it's actually subscribed to that other threads database, and it's using pubsub. So this was a really cool, really cool experiment. We did all sorts of crazy things with it. Built websites and did some like basic machine learning stuff, and did important things like do compound interest, which, interestingly enough, requires you to do recursion, which is something most people don't realize. And so we took this pretty far, but at the same time, this is very programmery, right? This is obviously just code. It's an interesting take on the code, and like I said, you can do some pretty impressive things in a very small amount of it. But we wanted to keep exploring. And at the time, we were still really stuck on this idea of, I really like the Excel thing. Can we find the way to make the tables work out? So we tried it again, and we showed this prototype at Hacker School. And this is the first time we've had a version of Eve that had a drag-and-drop UI editor. So in this, I'm going to build the incrementer button, which might be a little hard to see, but I right-click, and up pops a menu. It gives me a bunch of options for things I can create. I drag out a little box. It says button at the top of it. And I'm going to give my button a name because names are good, right? I call it incrementer, and I click the Get Clicks button. And if I make this view live and click the button, you'll notice for every click, I get a row inside of the clicks table. And as I mentioned before, if you wanted to make the incrementer button, all you need to do is sort of count the number of clicks inside of here. And so what we do is write an Excel formula. We count one of the things on the left-hand side. In this case, I counted event. It didn't really matter which one. And then all I have to do is drag the column up to the little bit of UI and ask me what I want to bind it to. In this case, the only thing I could bind it to is text. And ta-da, an incrementer button. So this was interesting for us for a number of reasons. For one, it was the first time you could build a bit of UI without writing any code. You notice, the only thing I did was write a single formula in there. You could do this in 30 seconds, which is also pretty cool, from start to finish. You go to some website, you can drag a button out, make it do anything you want pretty quickly. But we found that this obscured something very important, which might not be a surprise to you guys, which is, let's say I put a bunch of tables together, and there are all these joins going on, and there's all this filtering and all this stuff, and there's these formulas and whatnot. None of that is easily viewed in this little view that I have here, right? All you see is some headers and all of that. You lose all of the context to understand what the view is actually bringing in, what its sources are, what it's actually doing. And so we kind of went on an extreme end of this. So we decided, okay, we've been doing this for a while now, and we've done lots of toy examples. Let's do a real example. Let's completely clone Foursquare. Why we chose Foursquare is beyond me, because none of us actually had ever used it. But we did. And we sort of along the way had to build a version of Eve that was capable of doing something that complicated, right? And we still were interested in like exploring, well, can we fix that problem of context in the table thing? And can we make a much more powerful UI editor? And so I'll show you a little bit of what using this guy looked like. Let's see. OK, so I have my workspace over here. I have a set of tables and views and all sorts of fun things over here. And you can see I have a list of my favorite books, which is not, unfortunately, very long. And let's say I wanted to build a little list view of these so that I can see the name of the book and the ratings of them. And so what I'm going to do is create a new little UI page here. And one of the things we were interested in doing was replicating a UI editor that could actually realistically build something like Foursquare, right? One of the problems with WYSIWYG tools is they don't tend to scale up very well to deeply sort of nested or sort of very complex sites. And so we took a page out of the way designers actually use Photoshop to design these very complex websites. And we gave ourselves layers, basically. We called them groups. And so if I wanted to create a little box on here, and I want to have one of these for every one of my books, right? It's this nice WYSIWYG thing. I can sit here and change the color of my lovely little box and add some border radius, and I can stick some text into here. We'll put the title into this guy and change some colors, make it look nice, right? Center it. Great. And I can preview it, and surprise, it doesn't look any different because we haven't made it actually bound to anything yet. But if we want to bind it, all we have to do is take our favorite books, drag it onto here. Just close this guy up. Click preview, and you'll notice, hey, I have 4 things that say title. That's cool, because I have 4 books in my thing. And I can just say, well, I want the name there. And now I have the name. And we can make our text a little bit bigger so that it's not doing that bad. That's pretty cool. And we can stick a spacer in here. Oops. Stick a spacer, resize it. Now they have space in between them, right? So this is basically what you could imagine is almost like if you took Angular and then built a WYSIWYG editor for data binding on top of it, right? And surprisingly enough, this is all you need to then build something as complicated as a production-ready Foursquare. As another example, I mentioned we can build the incrementer, I guess. Let's see. So create a new page. Grab this. And I'll do the incrementer because it'll show you what queries look like. And I will warn you, it's horrendous. This was not one of our better ideas. So I put a button down here. And we can say, click me, exclamation point. Make it big. Center it. Pretty. Colors. Like that. That's the prettiest of colors. Right, and so, yay, we have a button, and if I click on it, we'll go and we'll see the clicks table has clicks in it again. So I'm going to create a view, and we want to count something. So I'm going to click this count blob here, and you'll see I get this crazy-looking thing at the top. Don't worry about that too much. But what I want to do is I want to tell it I'm going to drag the clicks onto here. So I'm counting the clicks, and I have to tell it, well, what are you counting exactly? Well, I'll count the event number, I guess. And then if I drag the result out, it tells me I have 3. Excellent. I have to do this. Don't ask me why. It's a bad idea. All right, we'll name it, and we'll go down here and go back to incrementer. And unfortunately, you're going to see a bug in here that I was not able to figure out why it's happening now. It didn't used to. But for some reason, it now duplicates my button. But if I do that, you can see, OK. Now I have the incrementer button again. And again, it's sort of an interesting way of working with this world, right? All I have are these tables of data. And I'm writing views over top of them. So yeah. So we built Foursquare with that. That was fun. And we didn't like it. The way of working with the queries, I didn't show you any more complicated ones because they would be just completely unintelligible, was really hard. And so we started exploring, well, how do we actually make it better? The table thing didn't seem to be working very well. And one of the things we realized is that when we tried to explain queries to each other, we constantly did it by drawing diagrams that looked like entity relationship diagrams. And so we're like, hey, well, what if we tried that? What if we just tried, representing all queries as entity relationship diagrams, or, some approximation thereof? And so we built what we ultimately released. We're all open source now. This is Eve version 0 in this screenshot. And you can see this is the famous triangle query, right, or the 3-click query. It's a pretty hard query to optimize for in databases. And you'll notice that it is just a triangle, which is wonderful, right? We have this very nice natural mapping to, I'm looking for a shape inside of the database, which is sort of the intuition we had, is that anytime you're querying for a thing, what you're really looking for is a shape. And so, you have this nice triangle of friends thing. You can see I can get sort of intermediate information about what's going on. I click on one of the friends relations, and I can see that table directly in line. So there's like this peeking mechanism and all that good stuff. And results are down at the bottom. Now here's another more complicated query. So this is one that has a bunch of aggregations in it. So it's like, well, let's calculate the percent of the total salary per every department inside of a system. So this is something that would be very hard to do in Excel. And the SQL for this is pretty awful, actually. So we did a comparison. We sat a bunch of people down and like, here's the SQL, here's a picture, and explain both to me, right? Then there's no statistical validity in that, but it worked out pretty well, and it was like the first time we'd actually seen people really understand a thing just by looking at it, and a couple-minute explanation from us of what it was that they were looking at. So we did this, and we built some things with it, but we weren't really happy there. This is a very nice way of sort of viewing a thing, but it is not necessarily the nicest way of building a thing. We actually did some work and made it very efficient. Made it very efficient, but we wanted to try something else, and so I'm going to show you one of our latest experiments. If you've followed my Twitter at all, you will have seen me posting things about doing Mad Libs again. And so I will show you an editor that is a slightly different take on Mad Libs. And actually, this will look rather similar to William's stuff. In a way. So, let's say I'm going to do that friends thing again, right? And if I put a question mark, it means I have some blank inside of here. I don't know what it is. And I can submit that, and you can see it actually renders it as some blanks, right? It's blank is friends with blank. And now I can add some data to that. So I can say Chris is friends with Rob, and Rob is friends with Chris, and Rob is friends with Joe. And if I submit those, you can see everything updates. So this is a little bit like that Mathematica-style notebook thing going on again. And I can scrub through these and see all my lovely facts about the world. And as with all the other ones, we can do some interesting things in here. So we can say, well, whoops. We can say, who is Chris friends with? You can see, well, we have one match. It's Rob, right? Or we can say, who is Rob friends with? And we can join. And the way we join is something like this. We can literally just link these together, right? So this is a kind of an interesting way of looking at the world. And amazingly enough, you can build all sorts of really neat things this way. So if we wanted to, we can gather all the people that a person is friends with. So you can see Rob is friends with both Chris and Joe. So I'm getting the set now instead of just each row individually. And we can change this. We can count them. Again, drag and drop. So now we have the counts. That's pretty cool. The way you think about change inside of the system is now I can add a new fact as a result of that. For example, blank has blank friends. Again, drag and drop. Chris, Rob has 2 friends in this case. We can see that. And course, since the last time I showed being able to then chart this, I am going to make a chart of all of these. It's a very interesting chart, of course. Right? So this is just, again, a very different take. And I'm not saying that anything we've done is the right idea or any of it is necessarily a good idea. But what I will say is that we have to start exploring this space more. You know, I know Jonathan is a big proponent of turning this event, right, into a congregation of the people who are starting to think about these things. And we have to explore, we have to experiment, we have to question our assumptions in every way we possibly can. Literally, the past year and a half's worth of work for us, we've thrown it away, right? We do it, and we do it over and over again to learn more, to understand more, to test it, to see what we can discover. And I hope more of you guys will do that too. So thank you.